So this next problem is to take that same piece of paper and make a box with a lid on it. So to do that, we would want to be able to chop this up, and so this is kind of the template for the box with this. So how would this work? So here's our base. We have to have the four sides to fold up, and then we'd have to have this piece to fold over top. So this would represent my top, this would represent the bottom. So how would I get the dimensions of this box? Well, again, the amount I'm going to fold up is going to be x and x here. And so this is pretty straightforward. This is going to be 20 minus 2x. Okay, so my volume equation is going to be volume equals the height times 20 minus 2x. And then I need to get this edge here. So I know it's 50 all the way across. So how do I just get this edge here? Right in there. Okay. So the way we can do this is this. If I fold this in half, there is my halfway line. Because I have this edge matches this one, this edge matches this one. So if I want to find out the red piece bit here, what I can do is I could take half of the 50, which is 25, and just take away 1x. I'm only going to take away that 1x there. Okay, and that's basically taking half of that 50 length and doing it. Okay, so this length from all the way across is 50, and that red line represents the halfway line, okay, of that 50. So then I have my third dimension, so 25 minus 1x. So there's the equation I want to generate. Okay, now again, I could do a guess and test model where I can guess my height, width, length, and volume. Okay, so, I could just go, 4 centimeters. Okay, and my width is going to be 12 centimeters. My length is going to be 21 centimeters. Multiplying that all together, what would my volume be? I can estimate that volume to be 4 times 12. Okay, so I get 4 times 12 times 21. I'm getting 1008. Okay, so we get a volume of 1008 cubic centimeters. Okay, and I can do a guess and test chart like that. But I do have the model for this, the equation that models this, and when I graph it, okay, now when I graph this, my graph's going to look like this, and I want you to graph this as well. Okay, so I'm going to have my graph that looks like this, and in fact, there's other parts of this graph, but really I'm going to just focus on this domain, okay, because that domain is set by this length here. Okay, I can't cut more than 10 centimeters off of this, and when I actually solve for the max, and it's important to understand that we cannot find that max right now. Okay, not till we do calculus, because that max is not symmetrically distributed across those zeros. Okay, in fact, it's moved over just a little bit. It's actually 4 point. Let's see, it's 4 point. If I'm not mistaken, I think it's 4.4. Yeah, it's 4.40. Okay, and that would represent the max. Okay, 4.40, and the volume was about 1015.17 cubic centimeters. Okay, so that's the actual solution to this problem. However, what really is important is being able to come up with the polynomial model that models this problem.